Okay, everyone. Today we're going to talk about quadrilaterals and specifically parallelograms. But first, we need to talk about quadrilaterals in general. So we have the quadrilateral family tree. Our basic quadrilateral just has four sides. That's all it means to be a quadrilateral. So underneath our basic quadrilateral, we have three distinct trees or legs. So the first is a kite. And a kite, by definition, I thought we had space down below. All right, so a kite, by definition, has no parallel sides, but has two sets of adjacent congruent sides. So that means that this is congruent to this, and this is congruent to this. Next, we have a trapezoid, which has one set of parallel sides. So in this trapezoid, the top and the bottom are parallel. Below trapezoid, we have a special trapezoid, which is an isosceles trapezoid. And that has one set of parallel sides, and then the non-parallel sides are congruent. So this is congruent to this. Now, the most special type all fall under our parallelogram. So a parallelogram has two sets of parallel sides. Top and bottom, and left and right. Underneath the parallelogram, we have a rectangle. So a rectangle has opposite sides parallel. It also has all right angles. Next to a rectangle is a rhombus, which again has opposite sides parallel, just like a parallelogram, because it is a parallelogram, but it has all sides congruent. And last, we have a square, which again is a parallelogram. Opposite sides are parallel, but it is a rectangle and a rhombus because it has all right angles and all sides congruent. So those are our quadrilaterals. Today we're going to spend quite a bit of time talking about a parallelogram. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So the properties of a parallelogram are opposite sides are parallel, parallel. When we name a quadrilateral, we always go in order. Doesn't matter what way you go, but you always go around. So this is parallelogram ABCD. So that means that AB is parallel to DC. In a parallelogram, opposite sides are also congruent. So that means, so I said AB equals or is congruent to DC. And up here, I forgot to do the other sides. So that also means AD is parallel to BC. And AD is congruent to BC. So opposite sides are parallel and congruent. Next, we also know that opposite angles are congruent. So that means angle A is congruent to angle C. And that angle D is congruent to angle B. Then we also know that diagonals bisect each other. So up here in my parallelogram, I'm going to draw my diagonals. So I have diagonal DB and diagonal AC, which I'm going to say intersect at E. So that means that AE is congruent to EC and DE is congruent to EB. Because bisect means cut into two equal parts. So AE is congruent to EC and DE is congruent to BE. So that's a lot to remember about parallelograms. So using that, we can find missing information. So in number 1, we know that the diagonals bisect each other. So that means that 2x minus 4 equals 10. So that means x equals 7. In number 2, we know that opposite sides are congruent. So that means x equals 16. Number 3, we know the diagonals bisect each other. So that means that 3x minus 2 equals 4x minus 10. Oops, I forgot the plus 8. So that means x equals 8. So I want you to pause and I want you to try 4 and 5. So number 4, I know that ik is the whole thing. So that's 4x plus 3 equals half of that. So that's 35 divided by 2. So that means 4x plus 3 equals 17.5. So 4x equals 14.5, which means x equals 3.625. For here, I know that TR equals 14, M equals 31. I really don't care about that because I'm looking for TI. So TI is just 14 times 2. So it's 28. Now we're looking for the missing angles. So in my missing angles, I know opposite angles are congruent. So that means angle 2 equals 140. I also know that the opposite sides are parallel. So that means 1 and 140 are supplementary because those are same side interior angles. So angle 1 equals 180 minus 140. So that's 40. And that's also how much angle 3 is. Number 7, I know that angle 1 equals 113 because its opposite angles are congruent. I know angle 3 equals 22 because my opposite sides are parallel. So 3 and 22 are alternate interior angles. I also know that angle 2 equals 45 because angle 2 and 45 are alternate interior angles. Number 8, I'm going to find angle 3 first. Well, actually, angle 2 first is 72 because those are vertical angles. And then angle 3 is going to be 180 minus 72 because those are supplementary. So that's 108. Now to find angle 4 or angle 1, either one, I have to think a little bit. So this angle up here is 40, which means this one down here is also 40 because those are alternate interior angles. And then here I have a triangle. So since that's a triangle, that means that angle 4 plus 40 plus 108 equals 180. So that tells me that angle 4 equals 180 minus 148, which is 32. And use the same idea to find angle 1. So this angle is 47, which means this angle is 47. So that means this purple triangle also has to add up to be 180. So that's angle 1 plus 47 plus 72 equals 180. So then I can find angle 1, which is 61. I want you to pause and try to find angles 1, 2, and 3 in number 9. Okay, so I know that angle 3 and 50 are congruent because they're alternate interior angles. I know that angle 2 and 180 make a straight line, so they're supplementary. So 180 minus 82 equals 10, oops, not 10, it's 98. And then for angle 1, I'm going to use this triangle. So I know 98 plus 50 plus angle 1 equals 180. Gives me angle 1 is 32. So the last thing we're going to talk about is how we can use this information in a proof. So I know that ABCD is a parallelogram. This symbol right here means parallelogram. You'll see me abbreviate parallelogram as the parallel symbol O-gram. So if this is a parallelogram, I want to prove that triangle ABC, which I'm making purple, is congruent to CDA. Well, if I know the whole shape is a parallelogram, that tells me that BC is congruent to AD and that AB is congruent to CD because I know opposite sides in a parallelogram are congruent. So parallelogram means opposite sides congruent. I can then see they both share AC, so that means AC is congruent to AC, which is reflexive, which then means those triangles are congruent by side, side, side. So I used the properties of parallelogram to get what I needed to say the triangles are congruent. If you have any questions, please bring them to class.